All right, welcome back. Now we're going into 10.5, and 10.5 is finding the area of a regular polygon again. The difference is it doesn't use special right triangles to find the measure of the work. It uses sine, cosine, and tangent. All right, so I can tell you to make this easier on you, the first thing you want to do is write down the correct formula. And we've talked about this. So area equals 1/2 perimeter times apothem. So you need two things. You need the perimeter and the apothem. All right, now the rest of it is picture-based and information that you already know. So let's start with a shape that has 9 sides. It's called a nonagon. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, not very accurate, but I'm going to put the dots there so you know that there's 9 sides. All right? So it's a nonagon. And you need the perimeter, so if you can find one side, you can find all of the, correct, all the others. Find the perimeter. And there's some things that you have to remember happen. First of all, how many degrees are inside of that? You have to use 180 n minus 2 divided by n to find the angle measurement. Okay. Now, you can use that to find the angle measure, and then when you draw the radius, what does it do to that angle? It bisects it. Okay. Now notice, there's going to be triangle work in here. So you could find this angle using this formula, and then cut it in half, and now we're dealing with the triangle work. Now this is why I draw this out. I draw the original shape, and then we draw the triangle, and I draw it bigger so that I can put measurements on it and find the things I need. So I'm going to use this. Now, what else could I use? Well, I could find this angle here if I wanted to. Okay? The central angle, that's what it's called, the central angle. Why? Because it's in the center. Okay? The central angle is always 360 divided by the number of sides. So we'll do both, and you'll see how they both give me the answers I need. Okay, here we go. We have 360 divided by 9. That would give me this angle measurement of 40 degrees. Okay? And being it's an isosceles triangle, adds up to 180. That would mean these two angle measurements are 70 because they add up to 180. Or I do the same thing over here, which was 180 times 9 minus 2 divided by 9, and I get 140. And when I draw this radius, so I know this measurement is 140, I know when I draw the radius, it bisects the angle. So that makes this measurement 70. Either way will work. Nobody cares. Do it either way. These measurements are going to be important because you're going to be doing right triangle work. So here we are. I found the measure, I found the measure, I found the measure. These are things you're going to have to do automatically. Okay, they're not going to tell you to do this. You have to find those measures of degrees. Okay, that's the first thing you're just going to have to do. All right, now, if they give you the perimeter and the apothem, then none of this is needed. But most of the time, they're going to give you a shape that doesn't have the perimeter or it doesn't have the apothem. It's going to have one of the two. In this case, I'm going to tell you that one of these segments is 10. Okay, so now you have the perimeter. 10 times 9 is 90. So I go ahead and write it there. There's 90. I have the perimeter. So I'm missing, sorry, not missing the apothem. All right, so I've taken this triangle that I know and I've written it here. Now I'm going to draw an apothem. Okay, and you notice I go through the central angle. So the apothem bisects the angle and it also bisects the side. So what are each of these little pieces? Correct, they'd be 5 apiece. How do I know that? Because the original side was 10. Right. All right. So here we have our right triangle. I have a measurement of 5, and I need the apothem. Well, this isn't a special right triangle, and I don't have Pythagorean theorem, so I have to use sine, cosine, and tangent. So I put my finger in this corner where 70 degrees is, and I go, I need the side opposite. So it would be the side opposite over the side adjacent. Okay. Opposite over adjacent is the function tangent. So my work would be tangent of 70 degrees is equal to x over 5. Okay. I solve for x. 5 times the tangent of 70 degrees equals x. Correct? The x is in the numerator, so I multiply by 5. If the x was in the denominator, I would just switch what's on either side of the equal sign. And if the x was the angle measurement that I needed, I'd use the inverse sign. But we'll always have the angle measurement, so we don't have to worry about that. The x will either be here or here. We're either going to be looking for the side, or we're going to be looking for the apothem. Now, if you wanted to, you could use the central angle measurement of 40, bisect it, use 20, and then use the tangent of 20 is 5 over x. But I would suggest doing it the same way every time. Now, what's nice? The nice thing about this is you're not using the hypotenuse yet. If they give you the radius, which is the hypotenuse, then you have to use sine or cosine. And you may have to use both, because if they only give you the radius, you're going to have to find the apothem and the piece of the side. So this triangle is going to look the same for every single one of your pictures. Your original picture is going to look different because it's got different sides. And then there's your sine, cosine, and tangent work. This is a process, okay? It's following a process. So here we go. Now I type it into my calculator, and I get 5 times the tangent of 70 degrees. And again, this is why you're using the calculators. You get 13.7. So the apothem is 13.7. Now I can do 1/2 or 90 times 13.7 divided by 2. And my area would then be 618.2 approximately, because I rounded. And we'll just say this was all inches squared. So this is one problem. Original shape, the triangle, drawing the apothem, knowing that the apothem bisects the sides, the apothem also bisects the central angle. Okay. And the radius also bisects the angle inside of the figure. So however you want to find the angles inside of each individual triangle of a nonagon or a hexagon or whatever you want to do, you should be able to complete it. All right, so let's look at another one. Let's look at an octagon this time. So now I have an octagon. Octagons are easy to draw because it's a stop sign basically. Okay, you have an octagon. And in this problem, they're going to give us the radius. The radius is 16.2. All right, So that's the original picture they give you. All right, so what do you need to do? You need to find the angle measurements automatically. So I'm going to draw a triangle because I know I'm going to have to. And I know the radius is 16.2. So on my triangle, that's this. Now remember, that triangle here and this triangle here would be the same. I'm just moving it over and making it bigger so I can put measurements on it and it's legible. Okay? There's no reason to save space on these problems. Okay, so I'm going to go with the central angle approach. So I do 360 divided by 8. And I get the central angle of 45 degrees. So that means this measurement was 45 degrees. But when I draw the apothem, I'm going to be bisecting it. So that means this would be 22 and a half. Okay? Why is this important? Because that's the angle right here, 22 and a half. The other side is 22 and a half, which makes 45. So I need both this, which is half of a side. Okay, this is helping me find perimeter. In other words, if I were to put this picture over here, you could see that if I found this measurement here, it's half of the side. All right, and then of course the dotted line is the apothem. Now you're drawing these pictures, so the dotted line is really not there because you have to put it there. All right, so if I start at 22 and a half, this side would be opposite, and this is the hypotenuse. So it's opposite over hypotenuse. What do I have to use? Sine, cosine, or tangent? SOHCAHTOA, remember? So you have these formulas. Hopefully you know you're using sine, which would be opposite sine of 22.5. And that's going to find me how much of the side again? Half of it. So now I do the calculator. Of course, I have to solve this. This would be 16.2 times the sine of 22.5 equals x. All right, so I type it in. 16.2 sine of 22.5. 6.3. Now remember, we're rounding to the 10th, unless they tell us anything. So 6.3. So this measurement is 6.3, which means the entire side is what? 12.6. So here's my formula. I need the perimeter and the apothem. Okay, 12.6. So 12.6 times 8 gives me the perimeter. So that's 100.8. That's finished. Now I need the apothem. So I go back to my triangle work, and now I need this section. Now I'm going to put y here, just because I know I need two different variables. So I put my finger there again, and this is now adjacent over hypotenuse. Adjacent over hypotenuse. This was opposite over hypotenuse. This is adjacent over hypotenuse. So adjacent over hypotenuse is y over 16.2. And that would be cosine of 22.5. And then again, it's 16.2 cosine of 22.5 equals x. Again, now I just type it in the calculator. The 16.2 cosine 22.5 equals, it's 15. Notice how we round it up. This would go to 0. This moves this up. It's 15. So that means my apothem is 15, that line. So I put 15. Now I take those numbers and I just put them into the problem. All right, and you end up with and we'll not 108, sorry, 100.8 times 15 divided by 2, approximately 756 inches squared. Now, if I wanted a more accurate I could put it all into one problem. Okay, if I wanted a more accurate number, okay, I know that I needed the perimeter, which was 8, and it was times this answer times 2, right? So it was 8 sides times the 2, right? Times the 16.2 sine of 22.5. That was my perimeter. That's what I did. This little piece multiplied by 2 gave me the side, multiplied by 8 gives me the perimeter, and I find x by using this. So 8 times 2 times the little piece. That's the perimeter. I found the apothem, which would be that. That was your apothem. Okay, and I've got to make sure this was y, I'm sorry. Okay, and then I can divide the whole thing by 2. So now I can actually type this in if I wanted to get the accurate, because when we're rounding, we're going to create errors. So I would accept this. But if you wanted to be accurate, you put everything in at one time. So we'll do the old fraction bar, and we have 8, 2, 16.2 sine 22.5 parentheses 16.2 cosine 22.5 parentheses and 2 hit equal. And notice this answer is a little smaller. Oops, sorry. We'll try that again so you can see it. I apologize. So we're going to type it in. 8, 2. Remember, we don't have to write multiplies. That's what the parentheses mean. 16.2 sine 22.5. Got to end the parentheses. Then 16.2 cosine 22.5. End the parentheses. Right? All over 2. And I start with the, sorry guys, start with the fraction bar. Okay, so now I have it as the whole problem, and notice that answer is smaller, but the only reason it's smaller is because of my rounding errors. Okay. This would be the exact answer. Now this is time consuming, but it's not really difficult. Okay, and it's taking usually the same shape and finding the measures in it. All right. I would say do the 2 got it problems, or do the 1 got it problem. Got it problem number 1, and then I'll use that as the stepping stone for the work. We'll go over got it problem number 1 when you come to class. You'll start on the work. All right. Have a good day.